Hello everyone, we will continue with an example. So some parameters are given for the induction motor. First of all, let's examine which parameters we have. It starts with the 408 volt. So according to specifications, the given values for the voltage must be the terminal phase-to-phase voltage. So we have terminal phase-to-phase voltage of 480 volt, and applied voltage frequency is given as 60. The output power rated value is 50 horsepower, and we have three-phase system, 60 ampere. It is also related to the input part, terminal part, so 60 ampere means the line current of the system, and the 0.85 lagging power factor we have. Some parts losses are given. Stator copper losses as 2 kilowatt, rotor copper losses as 700 watts, friction and windage losses 0.6 kilowatt, and core losses 1.8 kilowatt. And what else? The stray losses will be neglected for the system. So let's calculate some losses. For example, we can start with the input power. For the input power, we can use two different expressions. We can use 3 V phase, I phase, and cosine theta, or square root 3 Vt, IL, and cosine theta also. For the first one, we need to know the connection type. The system is connected in Y or delta, we must know, but it's not given in clearly for the example. But for the second expression, we can use our parameters. How? Square root 3, as I said, the terminal voltage, which is the given voltage of the system. So 480 can be used directly, similar with 60 ampere. And we have 0.85 power factor value will be 42.4 kilowatt. What else for the next part? According to given losses, we can continue with the air gap power value. For the air gap, we can use the power flow diagram relation between the losses and the powers. We can write input power, stator copper losses, and the core losses. So we have calculated the input power as 42.4 kilowatts. Stator copper losses and core losses are given 2 kilowatt and 1.8 kilowatt. So from here, we can find the air gap power as 38.6 kilowatts. Then the next one can be the converted power. So the converted power can be calculated again by using the power flow diagram relations. So the last power we have calculated is air gap power. Then if we use the rotor copper losses, we can find the converted power. So the first one is 38.6 kilowatt, and the rotor copper losses 0.8 kilowatt. So 37.9 kilowatt will be the converted power of this machine. And then the output power of the induction motor can be calculated. Again, we are going through the power flow diagram. So our lost power is converted power. Then we can use our mechanical losses, rotational losses. These are friction, windage, and the stray losses. So 37.9 kilowatts, 0.6 kilowatts, and the last one will be 0. It is eliminated for this example. So 37.3 kilowatt will be the output power. And if you convert this value to horsepower, if you make a unit conversion, it will be 50 horsepower, and it is directly exactly equal to the given rated value. So that means according to the specifications, given losses about the system, we can say we have loaded 100% this motor. And the last calculation can be the efficiency according to given values. So if we calculate the efficiency according to our calculations, the output power is 37.3 kilowatts and the input power is 42.4 kilowatts. So the efficiency will be 88%. Okay, thank you for watching.